We're on 3C.5 polynomial functions. Part 1. This is I can't talk. This is non-calculator. This is part non-calculator. Ugly. No, it's stuff that you could do. All right, so in our previous unit, we talked about factoring. Remember, 2B was all about factoring. Now, when it comes to polynomial function, factoring is important. The factors tells us the degree that we have. It tells us what our roots are, aka our x-intercepts are. And that's because based on the number of factors, that's how many times we cross the x-axis, right? And so when you look up here, we have x minus 2 times x plus 2. Because there are two factors. Let's try that again. There are two factors. Each factor only has a power of 1 on them. So that means that my degree equals 1 plus 1, which is 2. So this is a second degree polynomial. Does that make sense? How many factors? The number of factors. This is one factor. This is another factor. If there was another one, it would be a straight. Yeah. Okay. So the degree is 2. All right. So your degree is 2. That's the first thing you can tell from a factors. The second is, what are your roots, your x-intercepts? Okay. Your x-intercepts come from setting your factors equal to 0. So you're going to set the factors equal to 0. So I have x minus 2 equals 0. And I have x plus 3 equals 0. What is x minus 2 equal to 0? What would x have to be? So my x-intercept is at 2, 0. What would x have to be for x plus 3 to equal 0? -3. So my other x-intercept is at -3, 0. So we determine the degree and our x-intercepts. Degree, x-intercept. What are your questions? Huh? Saving paper. You don't have to write everything I wrote. All right, let's try it again. Okay, so on this one, to determine our degree, we're going to look at the number of each factor. X has only 1 power on it. This factor has how many powers on it? 2. So that makes it a 3. So this is a third degree polynomial. Yes? That's a factor. X, if you have an x by itself, it means x minus 0, which is just redundant. So it just equals x. Okay, so then our first x-intercept is at x equal 0. Our second x-intercept is at what? 4. So we found our x-intercepts and our degree. So this is good when it's given to us in factored form. Are you capable of doing it in factored form? Okay, here you go. Your turn. State the degree, find intercept. Is there a variable with it? So it's not a factor. Why? I don't think it's something. Oh, never mind. Oh, so it's whatever that is.
Like, I don't think I'm understanding.
It's the sum of the exponents.
But the negative doesn't have a variable with one like that. So it's just 3. So you basically pass out the exponent. I don't understand.
Do you see right here that this is x? It has a power to it. It's a variable. You see how this is a x with the number? This is a factor. It has a power to it. So your degree is the power of that one plus the power of that one, which makes it a third degree. This one has no variable. This one has.
Oh, okay.
So therefore it's a third degree. Yes? Okay, what's my intercept? 2, 0. That's the only one I have, right? All right, last one. Tell me my zeros and my degree.
Because it means that you finally but not follow.
Stop looking at it.
That's it. It's just really.
Guys, you need a book of make sure that it's on your. Or not, that's I'm making be a clown under the first. You would think it would be a clown.
It means that he doesn't have a value.
I think we should get rid of the third guy, you know? We need to bring that back.
All right, what do we get? Sorry. What's my degree? It's a fourth degree. And what are my zeros? Perfect. All right, so we're comfortable with this. We got it? Okay, cool, awesome. Now, graphs of polynomials. Graphs of polynomials are smooth and continuous. So if we've been graphing and identifying, notice that there's no breaks, no gaps, no holes, or sharp turns, correct? It's been smooth sailing, okay? The domain is negative infinity to positive infinity. It goes forever to the left and forever to the right. Remember Bob's dance moves? Okay. The end behavior depends on the degree of the function and the sign of the leading coefficient, correct? Bob told us that. He has 4 dance moves, okay? All right, now, multiplicity. So you notice how on some of our factors, it had a degree other than 1, right? 2, 3, 4, it can go on forever. That's called the factor's multiplicity, the root's multiplicity, okay? When you have a single root, it would look like this. It would just be r min x minus r to the 1. Right? That's a single root. What happens on the graph is that it goes through the point. It goes through the x-intercept. Okay? This is called a single root. A double root is x minus r to the second. That's our double root. R just stands for root number. Okay? And this one's a little different. It's going to sit at the point. Sit on the point. It's going to sit on the point. I like to call it, it kisses the point. I'm going to draw the pictures here in a minute. And then the last one is your triple root. And it's going to do, I call it a drive-by, but it's like it slowly creeps through the point. I am. Yep, slowly creeps through point. All right, here we go. So if I am an x minus r, a single roots are just going to go through the point. So notice that this is just a single root, just went through, smooth sailing. Okay. If I'm a double roots are going to sit on the point. Or you can say it's going to kiss the point. So notice it doesn't change direction. It's going to sit at the point. That's your double root. Okay. Here's your cubic root, your drive-through, your drive-by. It's going to increase and then slow down and finish its way out. Okay, it never changes direction and just changes its rate as it gets to the point. Hence why I called it a drive-by. Okay. All right, so do we see the difference in all of them? In one graph, you technically could have a single, a double, and a triple. Okay, so let's look at it. So how can I sketch without a calculator? I'm glad you asked. Step one is to factor the polynomial. So you make sure that your polynomial is factored. Is our polynomial factored? Yes. Step two is to find your x-intercepts, okay? So my x-intercepts are setting each one of these equal to 0, correct? If I was to set each one of these equal to 0, where would they reside? So my first x-intercept is where? It's going to be at the origin, and then my next one, and then my next one. Okay, so now I've identified where my x-intercepts are. Easy enough. Okay, the third step is to find your y-intercept. Your y-intercept simply comes from plugging in 0 to the function. If I plug 0 in for x, what is this going to equal? 0. If I'm already at the origin, that means my y-intercept is already at the origin as well. You could have multiple x-intercepts, but only one single y-intercept. Okay, then the last thing is to determine your end behavior. In order to determine your end behavior, you have to decide what is the degree of this function. What is my degree? 3. It's a third degree. And is my leading coefficient positive or negative? It is positive. So my leading coefficient is positive, so I'm going to be cha-cha to the right. So that means when we sketch this, we're going to start in the positive. We're going to go down, come up, and then go back down. I don't know why I got so shaky, but there's our sketch. What the y values are irrelevant right now because it's just a sketch. But now you have your general motion of your function. You can see that you have a relative maximum and a relative minimum. So this is my relative max. And this is my relative minimum. Why are they relative and not absolute? Because they aren't my highest, right? They're not the highest because I go forever up and forever down. All right, tell me how you feel. Did you survive the sketch? Ready to try again? Okay, we're gonna follow the same steps. Step one is to factor. Huh? Because we need a factor. We need to practice factoring. How do I factor this? Should always check for the what? Your GCF. Is there a GCF here? Yes, what's my GCF? X. So I divide everything by x, and I'm left with x squared minus 4x plus 4. So I'm asking myself what multiplies to give me 4, but adds to give me negative 4. Two and two. It would have to be a negative 2 and a 2. So x minus 2 twice. Does that make sense? So that's my factor. You told me 2 and 2. That's the last thing I wrote. Me too. I'm running on 3 hours of sleep. Now we do exactly what we did the first time. What are my x-intercepts? 2 and 0. I'm at 0 and I'm at positive 2. Okay, where's my y-intercept? It's also at 0, so I don't need to worry about that. And I gotta worry about my end behavior. What is it? What's my degree? What's my degree? 3. And what's my leading coefficient? So I'm starting off positive but ending negative. Now, this 2 is special. Notice it has a multiplicity of, what's my power here? 2. So what behavior is going to happen here? It's going to kiss. It's going to kiss. It's going to sit on the line. I don't actually ever cross it.
I have a question.
Yes. The degree is 3. Yep. That's why I pointed at it.
My graph on this one,
Good job. Why did we kiss at 2? What is that called? What did we just write? Back over. Starts with M. Multiplicity. Multiplicity. It has a multiplicity of 2, which means that it's going to kiss or sit on the line. Okay. All right. Let's see how you do. Go. You're gonna factor.
Miss, I forgot how to do that.
Let's start with your GCF.
What happens if you just have a power left?
What do you mean?
Like what if our power left?
You should have x minus 3 left.
Would it just be 1 to 3?
What's your degree?
1.
4. It says it right there.
But I thought I'd be factoring.
Your degree doesn't change.
So you take the factor from the original thing that you're using.
Yeah, your degree is not gonna change. Your degree and leading coefficient is what it is. What's my leading coefficient here?
Negative x to the power.
Mine is a negative.
So it goes down first.
And it's an even degree. So if I go down on the right, what I'm gonna do on the left?
Go down.
I'm also going down. Spear fingers down. Spear fingers down.
Now I'm stuck.
Your PCF is x to the 3rd.
So that it's like that.
Your curve would be divided by x to the 3rd, which is the greatest common factor. Yeah, so you're gonna factor off to the 3rd. Remember? Your PCF, if your leading coefficient is negative, then your PCF.
What you said? Oh, being
If I divide this by negative x to the 3rd, I think that's gonna represent the power.
Okay.
Because if you distribute this back in there, it'll be x. You didn't factor out. You have to divide x. Dividing x.
This was this, they have to say.
So if I have x to the 4 divided by x to the 3rd, that's gonna be 4 minus 3 is 1. See?
I don't know how to graph. Wait, maybe this is the 4. It doesn't have. So, yeah, can you explain? It also has, you don't know what you single, double, and triple. I thought they all have the same distance.
Ideally, but if you don't have that data, then you don't have that data. You use what you have. It's a real world problem.
Yes.
Yes, yes, yes.
If it's the 4,
4th degree.
how am I supposed to like slip lid on the thing?
So I'm the 4th degree and I start negative Therefore, I have to end negative. Okay? So when you ended up with this, negative x to the third became x plus 3. It's gonna it's x to the third. It doesn't go through origin, but it drives through the origin. It's a drive-by. Mhm. Yep. All right. So your x-intercepts should have been like this.
Oh wait, it's negative. I need to take. We're gonna do it.
Your leading coefficient was negative. So your GCF is negative. All right. And I am starting in the negative. And this has a multiplicity of 3. Because it has a multiplicity of 3, I am drive-by.
I cannot
Miss, how are you driving?
kissing it, driving by.
Well, it's a big difference between not sitting on the line.
So like you don't actually touch the point whenever you drive by.
You do. I just did a horrible example. Okay, there we go.
I do my stand. I don't want you. Girl, what is going on? We're just gonna color the rest of that.
It has a multiplicity of all right. Because it has a multiplicity of 3. I don't go straight through the point. So let's go back to the multiplicity chart. So when we had our multiplicity chart, guys, if we're good, I will stop teaching and you can start your assignment. Let me know. If you have a single root, we just smoothly go through our x-intercepts, right? If you have a double root, we're either going to kiss or touch the line, touch the point. So notice here, I do not ever go below it. I'm either going to stay above it, or if it was negative, I would be below it, right? When you have a triple root, it's going to be that slow creeping through it, okay? I'm still going to go through the point, but my rate of how I go through it is going to change along the way. Which is why when we graph this one, it has a little extra in it. What I said. Okay. Okay. All right. Try again.
Did not drive by.
Do you need an eraser?
Color that girl.
Bro,
yeah.
Yeah, I mean, I can use the rice.
The line was off now.
Whoa. That's four.
Yeah, but then you have that. Here's it.
You're welcome. All right. What's your GCF?
X squared.
It's just positive x squared. It's only negative if your leading coefficient is negative. My leading coefficient negative?
No.
No.
You can write the degree time. Down. We know we're gonna see adding up.
Good job. I love you. I got to a 1. I got to the 1. For the rest of my life.
So the
Factor out the x squared, you should have an x left of 20. And there was no negative. So why put a negative there now? There's no negative.
You're right. Okay.
It's just x squared minus x minus.
Okay, now factor. So what multiplies will give me negative 20, but add will give me negative 1.
So that means that you six more, so you have to get on that. So that means.
So it's x cubed divided by x squared. If you're factoring something out, that is you divide by that. Yeah, it's a positive GCF is really.
Okay, you have to. I
Oh,
explained
yeah,
this.
negative. Notice it was negative because I'm leaving it. See. Very carefully. So first you're gonna plot your intercept. So what are your intercepts? Okay, and then you're gonna do your end behavior. So. What's in the.
That means
Wave our hands like we don't care, right? That means I have to start up and end up. Yeah.
Okay, all right, guys, let's look up here. So for your factored form, GCF is x squared. So you should have divided everything by x squared, which left you with f of x equals x squared times x squared minus x minus 20. Simple factoring. What multiplies to give me negative 20, but adds to give me negative 1. What'd you get? Negative 5 and 4, x minus 5 and x plus 4. Yes? Okay, so because I have those, now I have my intercepts. The x squared tells me I have an intercept at 0, and it's going to be doing what at 0? It's a multiplicity of 2. So keeping that in mind, what should be happening at 0? I'm going to sit at that point. Next, you have x minus 5, which tells you your factor is at, your x-intercept is at 5. And then your last one's going to be at negative 4. You have a 4th degree positive polynomial. So you're waving your hands just in the air like you don't care. So I'm going down, coming up, going down, going up. It is a W. Single, double, single.
All I do was win it down.
Good job.
Yes.
Okay, so we had a single root, a double, and a single.